Hello, ladies and gentlemen. Today we are going to be reviewing factoring. And with factoring, we always start with our greatest common factor. After we take out that greatest common factor or look to see if it's present, we then look at the number of terms. And the number of terms tell us how to go about the problem. If there's two terms, the pattern we look for is a difference of two perfect squares. If there are three terms, we know we have either an a equals 1, an a doesn't equal 1, or a PST, a perfect square trinomial. If we have four terms, we look for grouping. So hopefully you had an opportunity to write down the 8 problems that are on the slide. If not, pause the video and go back and write down those 8 problems. We're going to go through those 8 problems together now. Our first problem is 12x to the 7th plus 4x. And so the first thing that we're going to look for is our greatest common factor. And if we look at this one, our GCF between 12 and 4 is 4. And between x to the 7th and x is x. And so that means we're going to be able to take and divide out a 4x from both of our terms. And so remember, our greatest common factor always goes on the outside. And then we're going to divide this part. This will give us 3x to the 6th. And then 4x divided by 4x will give us a plus 1. And we look inside here then to see if this can factor any further. Since this is a binomial 2 terms, the only other factoring pattern we would have is a difference of 2 perfect squares. Since it doesn't fit that pattern, this is our answer. Okay. The next problem that we're going to look at, problem 2, is 35x plus 21x squared y. And so the first thing that we're going to do is look to see does this have a greatest common factor? And between 35 and 21, we have a 7. And between x and x to the 2nd, we have an x. We have a y in this term. Since there's no y in this term, we cannot include a y in our greatest common factor. So now I could take that greatest common factor and divide both terms by that greatest common factor. Remember that that greatest common factor always goes on the outside. And now I'm going to be able to divide. This will give me a 5, 3xy. The last thing I should do is check to see, can this factor any further, meeting any of our factoring patterns? And since this is a binomial, the only other pattern we have is a difference of 2 perfect squares. This does not meet that pattern, and so therefore we are finished. This is our answer. So both problems 1 and 2 had to deal with problems that were only factorable by having a greatest common factor. Now let's look ahead to number 3. Number 3, the problem is 36x squared minus 4. So I always check to see if there is a GCF, and there is a GCF of 4. So I'm going to be able to take and divide a 4 out of both parts. And then I'm going to check to see, well, can this go any further or am I finished? Now, if I look inside here, this 2 terms, 9x squared is a perfect square. I have a minus sign and I have a perfect square here. So what pattern I see is a difference of 2 perfect squares. And so I'm going to drop down that GCF. That always shows up in my final answer. And then I'm going to be able to take this 9x squared and this 1. And I know that since this is a binomial, to have those middle 2 terms cancel out, that one of my factors would have to be a sum and one of my factors would have to be a difference. And so for this particular problem, I had to use greatest common factor as well as a difference of 2 perfect squares. Now for problem number 4, I immediately know that it's going to be a little bit different because it is a trinomial. It has 1, 2, 3 terms. I still check to see if there's a GCF, but this one does not have a GCF. But I know a lot about this. I know that x squared must be x times x. I know that if this term, my c value, is positive, that my signs in my parentheses here must either be 2 pluses or 2 minuses. If I look here, this tells me they're both going to be minuses. If I think about the factors of 56, I'm looking for factors of 56 that are going to be able to make a negative 15. And after listing those factors of 56 out, I hopefully can settle on 7 and 8. And so that my answers for this problem is x minus 7 times x minus 8. Okay, looking at problem 5. Problem 5 is x squared plus 3x minus 10. So once again, I look to see, is there a GCF? There's no GCF. This is a trinomial where my a value is equal to 1. This is in class where we talked about that, if you wanted to use this, I know some people are still using the box to help them, you can. If you're able to go straight to the parentheses, you can do that as well. Remember, the box just helps us visualize the problem that x squared is x times x. That if we need to make a negative 10, that we must have 1 plus and 1 minus. And we need to be able to make that middle term so that we have a 3. So if I were to put a 5 in here, that would make this a positive 5x. And if I would put a 2 here, this would make this a negative 2x. And that combines to make a positive 3x, which gives me my two factors of x plus 5 and x minus 2. The factors are what we're looking for. If you still want to use that box method to help you think through the problem, please feel free to do so. Right. Question 6 is 3x squared plus 5x plus 2. So I look for, is there a greatest common factor? There is not a greatest common factor, but I do notice two things. This is a trinomial, there are 3 terms, and my a value is no longer 1. And so now, even for someone who hasn't been using the box method, this may be one that you want to use the box method for. We know that since 3 is prime, that 3x squared can only be 3x times x. And we kind of luck out with this problem that 2 is prime. And so therefore it can only be 2 times 1. We also luck out that this is a positive, and it tells us that both of our signs here are going to be positive. So we just need to get the 2 and the 1 in the correct location to be able to make a 5. So what I'm saying is, do I put the 2 here and the 1 here, or the 2 here and the 1 here? And if we look at this, if I put the 2 here, this would give us a 2x positive. If I put the 1 here, that's going to give us a 3x, and that would combine to give us the 5x. So remember, one of the things that we can change is the location of these numbers to help us to get the correct middle term. And so our factors here are 3x plus 2 and x plus 1. Right. If we look at number 7 is 2x squared minus 3x minus 14. So no greatest common factor, but it is a 1, 2, 3 term trinomial. Our a value does not equal 1, so I am going to have to think through this problem. 2x squared can only come from 2x times x. But this time, I have a negative c value. So that tells me that this negative 14 could be a negative 1 times 14. It could be 1 times a negative 14. It could be negative 2 times 7. Or it could be 2 times a negative 7. I need to change and alter either both the location and the sign so that I not only make a negative 14, all of these sets will make a negative 14, but I have to make sure that it works out to a negative 3x. And so if I start by placing numbers in there, this might be one that you have to place and try a couple of times. But if I were to put the negative 7 here, that would give me a negative 7x. And the positive 2 here, this would give me a positive 4x, that then when I combine would give me the negative 3x. And this is definitely one of the ones that you might have to try a couple of different things by changing the location of the 2 and the 7, or the signs, whether they're positive or negative, to make that middle term work out correctly. So our factors that work for this are 2x minus 7 and x plus 2. Okay, and we're on to our final problem here. Number 8 is a problem that has 4 terms. And when we have a problem that has 4 terms, we use a process called grouping. So our problem is 2x to the third plus 2x squared minus 5x minus 5. And so we look at these 4 terms and we really group them into 2 parts. And so if I look at the first part here, 2x to the third plus 2x squared, I think about what's the GCF here. And the GCF here would be a 2x squared. And if I divide both of those parts by the GCF, I would be left inside there with a x plus 1. So that's what I've done. I've taken these 4 terms and I've kind of divided them, and then this is my first group. And then I'm going to come over here, I'm going to look at my second group. My second group starts with a minus. And so I immediately know that my GCF is going to be negative. And so I see negative 5x minus 5. My GCF is going to be a negative 5. And so when I link this together down here, that's where that negative 5 is going to show up. And when I divide, I'm going to have x plus 1. Now hopefully, if I've done this correctly, what happens is that this parenthesis and this parenthesis are the same, and those are one of my factors. The other factor I create from pooling together the 2 greatest common factors that I used with each of the groups. So this was the greatest common factor from group 1, and this is the greatest common factor from group 2. And so my 2 factors for this polynomial are x plus 1 times 2x squared minus 5.